Welcome again. I thought it was time to do a building engineering video again, because it's been a while since I've done that. The last time was with a bit of concrete in a flat in Enschede, and I've also done some videos in the area called Bonse Maten, which is a new housing estate near Hengelo, and I was kind of making some clips from a building project that I thought was kind of interesting to show in a few aspects, because the foundations are kind of interesting, and the way it handles the wind loads with the houses is also kind of interesting. These houses have strip footings, which is a type of foundation that is becoming more rare in the Netherlands, because most houses these days have pile foundations, and foundations that are directly being supported by the soil are becoming increasingly rare here, although here in the east of the Netherlands you might still find them in new projects. But another interesting thing about this project is that even though the walls use a calcium silicate masonry system, the wind loads are being handled by a precast concrete wall, and that is actually visible in the foundations, especially how it deals with the tension and the compression from the diaphragm wall. I'd say let's take a look at the first video, although I must say the audio is a bit windy there. In the later videos the audio is a bit better because there was less wind. And also, well, the weather conditions are kind of variable. You see a lot of Dutch weather there, very clouded skies, although on some days there was a bit of sunshine. So I'd say let's take a look. So here we are again at Bonse Maten, and well, here's a housing project under construction that has some interesting details. As you can see, it has a strip footing and calcium silicate masonry units that are quite tall, and there's a concrete bit with a little rebar cage for a column. But there's something interesting, and there you can already see a formwork. They are going to pour a concrete wall there with two large pieces of rebar sticking out. And that rebar is probably going to be used as a tension and compression system for a lateral stability wall, which will probably be made of precast concrete. And of course those two rebars are going to protrude into that wall with a grouting duct. So that's what I'm kind of expecting to happen here. So here we can see the foundation in a bit more detail. As you can see, the concrete wall has already been poured there, and there's the two pieces of rebar sticking out. The ductwork for the heating system and the sewage mains. And as you can see, the strip footing is quite wide, because this is directly supported by the soil. There are no foundation piles underneath this. But another thing that I noticed is this wall is not particularly smooth on the top, whereas with this block over here, the concrete wall is nice and smooth. So they finished that one nicely, but the other one, well, is just kind of rough. So here's another example. Let's see if I can find a place where they are already installing the floors, although I don't expect them to. Of course there will be precast floors for sure. No, it doesn't look like they have been delivered yet, because those blocks over there still haven't got the floors either. So this block, as you can see, is already in a slightly more advanced stage of completion, because they've already put some sand around the foundations. So this one is ready for the installation of the precast floors. The blue ducts are probably cold water, the red ones probably hot water. I'm not sure if they are going to use a heat pump, because I think these houses probably don't get any gas mains, because in the Netherlands they want to get rid of natural gas systems. So these may probably get some sort of heat pump system instead. I'm not sure, but I'm pretty sure they probably won't be getting any gas mains. But yeah, as you can see, the grey plastic pipe, that is the sewage mains. So the one that is near the concrete wall, I bet that's where the standpipe will be for the vertical sewage system. Of course, that one over there might also be something to do with that. Yeah, it's pretty clean and nicely laid out. They've nicely fixed those ducts against the wall. But those blocks, they are really large calcium silicate units, and they are normally glued. Instead of using standard mortar, they use a very thin bed mortar, which they call glue. But sadly, the floors have not been installed yet. So here's a place where they are still creating the strip footing. You can see the formwork, and there the concrete strips and the rebar. So over here, there you can see that the building pit has been excavated and that the strip footing is not in place yet. But as you can see, there are no foundation piles. There's still some small metal things sticking out, but those are just markers for the arrangement of the formwork. And they're just going to put some wooden scaffolding boards and some plastic foil, and then they're putting a small reinforcement mesh in it, and then they pour the concrete strip footing. But yeah, it's completely supported by the soil. There's no foundation piles, because this soil is pretty solid and well compacted. Although there are some other places in this neighborhood where the houses have foundation piles. So here you can see the finished strip footing. Over there at the end, the formwork is still there, and the strips have not been poured yet, and those are the finished ones. There's the crane with the blocks, and that's how they install them. It's just a very small crane that can just grip a block and put it in place, because those blocks are way too heavy to carry yourself. They would be more than 18 kilos, which you cannot lift yourself. It's just way too heavy. And those purple markers that you see there, they are also measurement markers for the alignment of the blocks. So they're probably gonna draw like a line on top of it, or they just span a string, and then they have a perfect alignment for the blockwork. So, and finally here we have two rebar cages for a concrete pier, and most likely there will be two steel columns on top of that to support the bay window, because that's kind of what this looks like. So I'm expecting they're probably gonna put some steel frame there which will support the floors, and yeah, have a nice bay window, because this opening here is quite big, so it has to be spanned with a well, a pretty heavy lintel. So I'm pretty sure that's going to be a steel structure. Like, I expect a box section, probably 80 by 80 millimeters, and then a HAE or HAB beam on top of that to support it. So that was the end of the first video. In the next video we're going to take a look at the ground floors, which are precast panels with lots of thermal insulation, and also a few more foundations. This time I have a video that was recorded in the course of 2 weeks. So the first section of that is very clouded weather, and the second section is much nicer weather. And in this video they're going to install some ductwork in the foundations. Also the ground floors are being laid in some blocks. In the second bit they're starting to build up the ground floor walls on the first housing block, where I'll explain a few things about the calcium silicate masonry units. So let's get to it. Well, we are now a week further and there's not much progress, but right over there are some precast floors installed. So let's take a look. As you can see, there are two black plastic buckets. They are covering up that rebar that was protruding from the foundation, and there are also some pink markers there. So that indicates the position of where the interior part of the wall is going to be. Since the GoPro doesn't have a zoom lens, you probably can't see it, but they wrote some crosshairs on the floors with a pencil, and then they drew this pink circle around it, and those are the measurement markers. So on the interior part they're going to put some wooden posts for the dimensions, and yeah, that will be used for the alignment for the walls. But these are precast slabs, and they are quite wide. They consist of two prestressed ribs and then a very thin concrete layer between them, and yeah, the rest is all thermal insulation. And then that floor on the corner there, where the bay window is going to be, you can see that it probably has a rib going in that direction and then one kind of at the edge, but I'm not sure. It looks like it just has a few notches there, a few bearing notches, because those ribs of course are, well, they are covered with insulation as well, but they need to be bearing on the foundation. So there are a few small notches where the actual slab bears on the foundation to also transfer the load from the walls. Here's another look at the floors, and right over there you can see that that floor panel has like an edge. It has some sort of edging profile, and that is like the normal edge profile that you get between two panels. But since that panel is kind of cut in an L shape, it doesn't have that other bit. And right over there you can see like the edge of the structural rib, and then the thickness of the insulation with the really thin concrete slab. And that concrete slab just has a well, a rebar mesh in it, and then the ribs are pre-stressed. Yeah, it's a very neat and very lightweight system, but those rebars are covered with buckets, probably for safety reasons. Big rebars can be pretty pointy, like spears, especially if you fall on them from great heights. This is why they often put like orange plastic safety caps on them on some construction sites, but here they're just using a few simple buckets, which is also very effective. So we are again a week further here in Borne, and let's see how much progress they are making with the walls. I am already seeing some calcium silicate units there being put up. Looks like the ground floor is being built. So let's take a look. As you can see, there are now more floors laid for different houses. That one already has its floors, that one has the floors. So there's some nice progress now. But of course I am kind of interested in the walls. So as I was expecting, they're going to use calcium silicate units, and these are well, pretty big masonry units, and they're quite smooth, as you can see. And these have a quality of CS12, which means they have a 12 Newton per square millimeter compressive strength. So that's very typical for a residential building like a house. And these units are quite big. They're using a little crane to erect them. So the first house is being built now. The ground floor walls are being put up. As you can see, it's not quite finished yet. I still see those two buckets there with the rebar sticking out. I am still expecting that there would be some precast concrete wall there. But yeah, the rest of it is calcium silicate masonry units. As you can see, one story can be built up from 4 blocks, and the story height is typically 2.6 meters, so you can kind of work out how big these blocks are. And of course it's a cavity wall, so those are essentially the brick ties, and that ties the inner and outer wall together. And there you've got the precast lintels. Those are concrete lintels. It looks like they're probably going to install a steel angle profile on top of it, because these are really just filler profiles. They're not going to be load bearing. They're actually going to use a steel angle for that. As you can see, above the lintel there's a little bit of space left, and in that space the flange of the steel angle will be sitting. And of course that's probably going to be a angle well, of a 100 by 200 by 10, something in that order of magnitude, just an angle profile, and that is going to be bearing the precast hollowcore floors. And as you can see, the walls are also temporarily braced with well, diagonal bracing to give the structure some support for the wind loads when it's being built. And yeah, as you can see, the joints are very thin. They are thin bed mortar joints, and because there are so few joints, the wall is actually pretty strong. And there you see the little crane that erects the blocks. Because the blocks are big, there are very few joints, so the chances of air gaps are also kind of minimized as well. Although there with the lintels you can still see some, well, gaps between them. That's kind of normal. But compared to traditional masonry, where you have a lot of joints, you also have a lot of chances for gaps. And well, that negatively impacts the thermal insulation and the air tightness. With this system it's much more controllable. And also because of the smoothness of the blocks, the walls are nice and even and very easy to finish. You don't really need thick layers of plaster, just a really thin layer is sufficient to make the wall smooth. This is the third and final installment of the short mini-series of the housing construction in Borne. This time I'm going to take a look at the hollowcore floors that they're going to use for the first floor, and also precast concrete walls in a little bit more detail as they are now being installed. In the second part of the video, which was recorded just a week later, I managed to find some ground floor slabs just laying by the road, and I was able to go into a little bit more detail about it. So let's get to it. So we are a week further now. As you can see, a few more houses are being built. They are already putting up some scaffolding, and here's the crane that places the calcium silicate blocks. As you can see, it's a small little crane, and yeah, it's very fast and efficient because those blocks are really heavy. Just one block may weigh like 50 kilos or something. probably even heavier. So that's what that crane is for. But yeah, scaffolding is being put up, and I already saw a trailer with some precast concrete walls. So let's see if we can get there. Oh, and I spotted this. There's some steel, some angle profiles which are going to be used as lintels, and then two big HEB beams with some things attached to it. I reckon they are probably going to support the bay window that is over there. So there's two beams with two angles attached to it, and those holes are used for attaching it to the hollowcore floor. So this is the scaffolding, very standard, very traditional scaffolding. It's not a specific system, this is just a standard scaffolding using pipes with clamps and then scaffolding boards. As you can see, the precast wall is not installed yet. So here we have the hollowcore floors, the precast floors that are going to be used for the first floor structure. And let's see which manufacturer this one is. This is a Consolis VBI. That's a very big manufacturer. I have been in their factory in Friesland for a specific project. They also have a production plant in Husen, and I think these are manufactured in Husen according to that label. So that is their other factory near the river. Yeah. This panel is 3.3 meters thereabout. It's an A200 model, very standard. And this is the special model, which probably has a thicker flange. That's the standard A200, and that is the AL200. That's a different model. And this is also an AL200 because it will probably have ducts for various installations. And that is the thing they're going to use to lift the panels. And these are the trimmer angles for the stair openings. That one is supported by one slab, that is supported on the slab, and then two or two and a half slabs are then supported by that angle. Yeah, this is the opening for the ductwork. That's why this is a different type with a thicker bottom side. And this here is a special panel for the staircase opening, because the trimmer angles have a standard length and the staircase itself is smaller. They need to fill up the hole. Well, and there we have it. Those are the precast concrete walls. And they are going to be connected with those two bits of rebar sticking out of the foundation. And there are some well, fixtures for attaching screws and temporary bracings. For instance, like that, it's probably a bracing fixture. It of course has the electricity ducts installed in it. And right over there is a gain. It is a corrugated steel tube. And that one extends all the way until the bottom. And then the rebar that is sticking out of the foundation gets into that hole, and then they grout it up. And over there is a lifting anchor. And I can't see who the manufacturer is. The label is not really visible enough. And here are the pallets for the interior walls. Those are non-structural walls. They are made of a very porous material, and they are very lightweight. So this is another example of those AL200 slabs with the thicker bottom flange and the space for the ductwork. So this is where they're going to put mechanical ventilation systems or HVAC systems into. And here are some more examples of that. Oh, this one is manufactured by Van Wijnen. Interesting, I didn't know that they manufactured these. But yeah, those panels over there, they are used in conjunction with those. This is where a standard panel will go. And then, well, you can see the spacing here. Here is a thing to attach it. This is probably like space of one panel. And then, I think maybe two panels. Not really sure. And this is a, well, I think a 200 by 100 millimeter profile. And this is like a 200 by 200 profile. And this is all nicely welded. We are here again at Borne another week later. And now you can see the precast wall has been installed. As well as the Hollowcore floor slabs. Also the trimmer angle is installed for the floor opening. And you can see that everything is well braced. There you can see the precast wall and the floor opening as well. And also the interior wall pallets have been well hoisted into the building, and they are installing anchors for the window frames. Like you can see here, for instance. There they can install the bay window, and they are also installing the steel structure. As I mentioned last week, there's a steel beam supporting the Hollowcore slabs, and then there's two angle profiles that will support a small roof for the bay window. And over there we have the window frames. So as you can see, they have also started work now on the walls for the other houses. And there is a concrete pier for the bay window column. So here's another group of houses with only the floors. And here we have the precast concrete lintels, as you can see. And they are, well, probably pre-stressed. So it's, well, pre-stressed concrete. It's a very high type of concrete, and right over there, the GoPro camera can't zoom in on that, but there's a label with the manufacturer, and it looks like these are manufactured by Fibo. So that kind of makes sense. They make a lot of these concrete lintels. And there we have some floor slabs. So here we have the precast concrete floors for the ground floor. These are the insulated slabs. As you can see, this is the structural rib. This is the actual supporting bit. And then here's the flange part that is actually quite thin, only 5 centimeters. And the rest is all polystyrene insulation. And there's a bearing notch somewhere here. And a few bearing notches that are embedded into the insulation over there, which transfer the load from the walls. Well, and here's the groove profile, where the two panels join, and this is grouted with cement. And the interesting thing is that they use this polystyrene insulation also as the formwork in the factory. In the factory they have a very long sort of formwork that is perhaps 100 meters long, with this polystyrene thing on top of it. And then they insert the rebar, and then they pour the concrete, and then they can kind of cut the panels to length. And here is a label of the manufacturer. This one is made by Beton, and I think that is a factory somewhere in, I think, Brabant. I'm not really sure. Let's zoom in on that a little bit. So this is the number of the panel, number 262, and production date, and the weight. It's 1 ton, and this is the order in which the panel should be installed. They also make a drawing with the arrangement of the panels, and every panel is numbered in a certain sequence. Oh, and that is actually a panel that has been cut to fit a certain size. Well, and here's the thing for lifting, the hoisting eyes, and this is just a bit of rebar that is embedded into the structural rip. So, the hoisting ice, that was the end of the video and also the end of this short mini-series. Well, I hope you enjoyed it and learned a few things about the construction process of a typical housing estate in the Netherlands using the calcium silicate masonry block system, the hollowcore floors, the strip footings and the like. That's it. I had quite a bit of fun just taking a look at it and kind of documenting it, even though most of the stuff is like a pretty common thing for me as a building engineer. But of course to the viewer it might be something completely new. I hope you enjoyed this short mini-series and I'll see you in the next video, probably with something completely different. Bye bye!